Hey guys, welcome to my next update. I've got some bouncy particles here, which I've got working quite nicely. Took a while, but, yeah. But first, I want to show you the cloud scene node. In my previous video, I mentioned that the new cloud scene node will not go behind the skybox, but now I've got it to appear behind the skybox of the see the distant hills. Looks pretty good, doesn't it? Wasn't that hard actually, it was relatively easy. I'll just show you. Okay, I'll just show you how updated the code on the cloud scene node. So all I had to do is change the registration of the scene node to what type of rendering section of the render to Skybox, and in the scene manager, which is your central hub for pretty much everything, there's an array called skybox list. It adds it to that skybox, just the node, and in your game to get the so that cloud scene node is just a 3D node. It's just a transparent. Don't know if it even needs to be dynamic actually, but anyway, I've just stuck it up there. But it's really just the parent of the cloud scene node. That's really what it is, and it gets adjusted in the code anyway, the position and everything else. I've just put it in the central position up a bit high, and that will be the parent. So firstly, this is the order of, it does the stars, then does the sun, does the planet, then does this ambient sky, and then it does aurora, and then the clouds, and then the hills. So those hills in front are the last things in order to get. So it has to be in order from top to bottom. It'll just automatically just pick out the first to the last and put it back into this array list called skybox list. And it will actually render, even though it's not a skybox, it'll pick up the actual code, which is located here in a different file. But because it's considered a skybox, that's that array and render it in that order that you want it to render in. So this is register node for rendering. It just goes through all your things in your level and orders it into different arrays. That gets it seems to be updated every frame. It seems incredibly wasteful to do that, but anyway, I might change that. But that's I might get it to update only when you make something visible or invisible, and on start. That would be way more efficient actually, but it's updating it, it's deleting it back to 0 every frame and then redoing it again. I mean, that seems incredibly inefficient it seems to me. But anyway, here's the order of rendering. Draw registered 3D nodes. It's part of draw all. And when at the drawing part, after all the animations, calculations, everything's done, and then there's the drawing part. So that firstly does camera, then the lights, then the skyboxes, solid nodes, then the shadows, transparency, and then other bits and pieces, one-off cases, bits and pieces there, and that's it, yeah. And then after all that, there's the post-processing after all that's finished. But yeah, so the skybox is fairly reasonably early on the list. So there's the array list. And it's just to render all those sky. It goes one from the start to the end, and if you order it in your game in the right position order, it'll render it as you'd expect. The order of the cloud scene node can render behind the skybox hills. Now these skybox hills is transparent. That sky part is all transparent. There's no. It's so that anything behind it can show up. In other words, so. Yeah, so I had to remove the sky, if you like, from each of these textures, and then put it as transparent alpha. So that works quite good. Yeah, so that was relatively easy yet very excellent thing to have. So that's fixed that. So we've got our clouds behind the hills, and my little weather thing is working not too bad. I think I should make that slightly bigger. That one there, it's not too bad, pretty good. Yeah, it looks alright, isn't it? It's not too bad. The clouds will get darker over time. Yeah, so I'm going to have a basic internal temperature thing working there eventually. But yeah, you can see the clouds behind the hills. That's pretty good in front of everything else. It gets dark over time before it starts raining. Yeah, and the yeah, so that works pretty nice. Now, in terms of the these bouncing particles, collisions is turned off by default, but I've had to adjust the code quite a bit. So it's going through things by default, and I'll turn on collisions. I press a button and it just makes collisions as true. So there you can see it's bouncing. You can change the maximum number of bounces before it... Hey! Maximum number of bounces before it finishes. Yeah, so it's bouncing pretty nicely off all the surfaces. Look, on occasion some particles do get through. I don't know why that is, or maybe I need to normalize the normals on this mesh. Maybe, I'm not sure about that. Occasionally it just does get through. Some of them do get through. Pretty cool weather, huh? Yeah. Anyway, so this bounce particle, you can limit how many maximum bounces before it despawns. Yeah, pretty nice weather system, huh? Yeah, pretty good. Needs a bit of work, but it's getting there. So if the lightning strike is closer, it gets louder. That's worked out quite well that way. See if we can see a lightning strike. Maybe not, huh? I think we missed it. I think I need to change the lighting as well. The lighting is not right. It needs to be a lot brighter when a lightning strike, actually. Yeah. Anyway, I'll work on that a bit more later. I think it's... There we go. Yeah. Haha. Well, we'll get some... I'll make a nice particle effect when it hits the ground too. Like a bit of an explosion, I think. Yeah. Yeah, you can get struck by lightning in my gaming. It's quite a nice little effect. So the clouds have gone transparent. All good. Anyway, so back to the particles. You can see it bouncing. I think by default I've got it at maximum bounces number 3. The more bounces you have, it has a little bit more impact on performance. Now, in terms of when you activate the collision, see that there? Collision triangles, 561,000. That's the collision triangles in the entire scene. By default, that's a little bit inefficient way to do it on especially large terrains. If you've got like a small size terrain, it's probably not a big deal, but it will have some impact on performance. The number of bounces and also the number of polygons in your level. There is an optimization I could add to it so that it only looks at the triangles within a large bounding box. Everything else is excluded. So if you had a big large bounding box around the player as it's moving and just looking at the triangles in that area, that would be a way more efficient way to do it. But anyway, let me know if that's a major issue for you. May look at doing that. Okay, so by default I've got the maximum number of bounces limited to 2. So first bounce and then the second bounce, and then after that, on impact to the third one, it will just despawn, be removed. But you can change that to whatever you want. If you put it at 0, it means there'll be no bounces and it will be deleted on impact. So that can work too if you don't want it bouncing around. Now, in terms of the way it was doing it before, I had to change the gravity setup. So if you enable gravity, which you have to do, if you want it to bounce up and then curve over and across and back down like you would expect, back towards the ground in a natural way using gravity, you got your initial direction here, and then if you're going to enable gravity, which you would probably want to do, I've got it at a high time, but this gravity affecting time no longer works. I've removed that from the code because it was causing problems. I've got it like constantly on all the time, but only at certain sections. So it's always, once you select gravity on, it will then enable it. And this figure here, you're only using the Y value, the vertical up and down position. The other two, X and the Z, are irrelevant. Doesn't matter what you put in there in my code. So I'm only using this figure here, and that should not be more than about half your standard vertical change in height here. So about half or less. If you put too much here, you'll find that it won't bounce at all. It'll just hug to the top surface and probably just slide along the top surface for a while, something like that, or it won't bounce at all. Yeah, so no more than about half the size. Gravity force. Now, in case you didn't know, all these things here can be adjusted by your JavaScript code. I don't think anywhere in the instructions it actually says this in detail. I'm pretty sure it doesn't actually, but I'll show you these are all the things you can adjust. Direction, max angle degrees, emit area, dynamically, or in code, with your code you can change it all. Minimum, maximum lifetime, max particles, minimum particles per second, max particles per second, minimum start color, max start color, minimum start size, X and Y, fade out, if you want it to fade out, fade time, fade target color, fade target alpha. You can change all of that. Gravity you can change, I was just talking about there. Gravity force, so gravity here would be like true or false, whereas gravity is the gravity force itself that you can change. Change scale, scale to X, scale to Y. Collision, this is the new stuff I've added. That'll be true or false. So you first turn collision on, it's off by default. By default, it's off. And you can also adjust the maximum bounce, number of maximum bounces. By default, it's 2. You can make it 0, 1, 2, 10, whatever. The more bounces, it will affect the frame rate a bit though. You can play with that. And when it starts up, it just gives you a bit of debug information, how many collision triangles. By default, it uses world collision, so in the entire scene, all the triangles in the entire scene. It's not particularly efficient. Ideally, I should just use a big bounding box around the player or around whatever you want it to do, and say, give me all the triangles in that area, and just use that. That'll be, you'd probably get about 10% of the normal triangles that way. It'd be a lot more efficient actually. And so the way I've done it, I've recoded it to match much closer to the way I created my own particle system, the player particle system, if you've seen that. It matches that very in a lot of ways actually, and it's way more efficient than the way it was done previously. Previously it was going through firstly, gravity effector. That was causing a lot of problems because it changes the amount of gravity over time, and that's not generally how you want it to operate. It's the way I've got it to have. So on every single frame, it goes through the entire list of particles, adjusts the gravity based on the effect, how much time you've used of that you want the gravity to affect it. But I've removed all that code because I found it irrelevant and unnecessary, and it caused problems, and I just simplified it massively. So instead of okay, so I've got here, if we're using gravity, I'll use the gravity force, but here's my simplified code. So what happens is it'll only apply gravity if the particle is going up in the air in the rebound. It's collided with something and it's rebounded up into the air, and you want to apply gravity back again. So it's come down at an angle, it's hit something, and then it's gone back up. So once it starts going back up, that's when the gravity starts kicking in, and it will curve its way back down to the ground until it hits that same angle again, and it'll just keep that same angle you had before until it hits something else, and it'll keep doing that. So that's pretty good, way simpler. So in other words, the particle vector on the Y going down, you're going up in the air, you're not going down, then it will apply gravity, the Y position of the gravity, to the vector of the particle, only up until it's it's not going down. In other words, the same as it was when it started, that created the particle in the beginning. So that works quite well, very simple. Here's a collision code. Yeah, so it's saying if it's collided with something and the gravity is applied to it, no longer applied to it because it's come back down at the same angle that it's now supposed to, and if its bounces are more than maximum number of bounces more than 0, and it's currently less than the maximum that you're allowed, then give me the new vector, impact vector, to bounce back up again. Otherwise, erase it. And if it's not collided, and if now the coming down angle is matching the original vector coming down after applying gravity, then give me the next impact collision point. So it only does that once, finds the impact collision point only once in its after it's on start or after its last impact. It doesn't keep calculating it. The way it was doing it before was having to keep calculating it all the time. I mean, that's very inefficient. Okay, so the code I borrowed from originally was from Joshua Jones from the Irrelict forum. I managed to download this code. A lot of this stuff is no longer available on the Irrelict forum. A lot of the code uploaded like 10-15 years ago, you just can't get it anymore. And if you do, you have to use it. I had to modify it massively anyway. I really didn't use much of the code ultimately because I had trouble getting it to work, and I realized eventually it probably wasn't the code, it was the gravity was too much and it was stopping it from bouncing. So I've got all this collision effector. So this is the original code, but I didn't actually end up using this code very much at all actually. Yeah, this is pretty standard stuff anyway. You can get this off the standard Irrelict web page. So world, get the triangles, but I didn't even use that. You can actually get just the triangles from particular 3D nodes if you really want to. I did it that way in the beginning and it was working fine, but I found it just seemed to be a bit nicer just to get the whole lot of the scene actually. You can bounce off everything then. That's pretty cool. So I didn't end up using getting the limited number of triangles from a particular 3D node or 3D nodes. Didn't end up using any of that. The way this was set up before is every single particle will count here, which is every single particle in every frame, go through all the triangles in the entire list of the triangle count, which is world, which here is just called world, and then firstly it would check every single triangle if it's within the current position. So that means that's from the line start and line end, which is the line start is the current position of the particle, v is the position plus the vector. Pretty sure that's how it's supposed to be. Anyway, so the start and end position in its current trajectory, it's running this every single frame to see is every single triangle, any of the triangles within the within that line, and then so if it's not, it excludes it. So continue means okay, just forget about it and run the next for loop. But if it does find it's potentially that line is within intersects one of the triangles, it'll then go through and get the triangle, get the normal, normalize it, and get the rebound vector, which is this little formula here. But that's also on all this stuff is on the Irrelict forum anyway. So I don't really borrow any of the code here actually. I originally did use it, but then I removed it because I didn't need it. I was using all that. You can use all that to set up a particular 3D node as the total list of triangles. I mean, there are ways you can include and declude specific, nodes, like a number of 3D nodes, and not all of them. You can do it that way too. But anyway, so I didn't end up using that hardly at all. But I did use it in the beginning, and I couldn't quite get it to work until I realized it was this gravity force. That figure there was getting too high and it was causing issues, and what it was do, it hit something and just slide along the surface all the time, wouldn't bounce anywhere. Anyway, so I changed the code myself, and I think this is a way more efficient way to do it. So it's finding the collision point once and once only, and then it records. So I've added some new stuff in the structure of the particle for each particle. Collision, true or false, the collision position, the collision triangle, so it gets recorded, the actual triangle. Doesn't need to recalculate it and check it every single frame. And there's your bounce number, current bounce number. And yeah, so yeah, that works pretty good. Yeah, so working quite nicely, really. And I simplified the code here as well. This is a lot cleaner now. The effect system was very, very inefficient before. The old way of doing it is, firstly, if it's a fade, if it's either the fade out effector, the gravity, or scale, it would go through the entire list of particles all over again from scratch. So if you got that happening, then go through the whole thing from start. And then if this is happening, go through the whole thing from start. I mean, then again, this one, scale effective, doing that, if you're using that, go through every single particle from scratch. I mean, that's just unnecessary. So I cleaned it up. So it's saying if you're not using any of this, return. Otherwise, there's your particle size. You're using that once throughout the whole thing, and you're just checking each thing along the way. There's your S particle from the array, and it just goes through if you're fading out, if you scale, if your gravity, if your collection. It just does all that. Yes, that works pretty good actually. And you can see it was running pretty well. It does have some impact on performance, of course, as you would expect, but this is probably as good as you'll get it. If you wanted me to modify it, to change it to not use all the whole particles in the whole scene, that'll be a nice optimization. Instead, use a bounding box, and you can change that bounding box size as you like and update it as you like. So theoretically, you could just look at the player position and update the bounding box around the player and just say, okay, within a certain distance around the player, give me all the triangles, and just use that as the triangle list. That would be way more efficient actually. But anyway, for now this is working. Yeah, it works pretty good. Took a little bit of mucking around because in the beginning I couldn't work out why it was not bouncing. It was just sliding on the surface all the time. Yeah, it took a while. I almost gave up actually, but anyway, we did work it out eventually. So, which is good. So I had to add some new stuff in here. Simplified the code, cleaned it up a little bit. Alright, so here's the two particle system. This is like your top level running it, and there's the time it gets fed into it. So it firstly does emit the particle, then do any affecting code to the particle, like gravity or collisions, blah blah blah, and then it goes down the list, and if it's past the end time of the maximum time frame of the particle, then it erases it. Otherwise, here it is. Here's your particle vector multiplied by scale. I think that's not actually. I think that's a delta time. I believe it is. That's actually like a delta time. So so it's a constant speed, no matter what the frame rate. I think so. There is time minus last emit time. That's actually. See, scale equals time diff. That's like a delta time actually. Sees the bounding box, updates the bounding box. I'm not sure why that's needed, but anyway. So here it is here. Say particle position, add the next vector, change in position, direction and scale, multiplied by delta time. Yes, okay, so yeah, that's pretty straightforward. And then some sort of bounding box updates. I'm not sure why that's done, but anyway. Okay, so in the code, what you need to run to get it to work is just get the name of the node, particle system, whatever, put the name, create a node, name of the node for it, and then just say collision true. If you want to activate collision, just put true. You've also got the ability to change the max bounce to whatever you want. You can put 0 and it will delete on impact, or you can have one bounce and then on the next impact it deletes. So it'll record that bounce for each particle, and if it's more than the maximum that you set here using max bounce, it'll then delete it on the next impact. You can have, say, whatever you want, as many as you want. I think it defaults to 2. I've got it to default at 2 to start with. So first impact, then second impact, bounce. So bounce, and then delete on the third one, in other words. Yeah. Yeah, so it's pretty good. So yeah, if you wanted to update anything of the particle system dynamically, there's the list here. Once again, the different in red is the actual JavaScript property name that you can modify. Yeah. So the only two I've added in are collision. So just turn true or false and max bounce. I mean, it should be max bounces, I suppose. But anyway, just call it max bounce. Yeah. And by default, max bounces is limited to 2. Yeah. All right. So once again, you can see the. I'll press D, activate the collision, and we've got collision, bouncing particles. Yeah. If you want me to change the add a setting to just how much bounce effect it has, I mean, I can do that. I did have that, but I find that bouncing at the same rate that it comes in at, it probably looks the best anyway. Not really needed to change anything. Yeah, and you got gravity affecting the particle, so long as it's not coming down at the same angle. So once it starts to bounce up and it'll keep applying gravity to it until it reaches the previous y value of your standard direction. Yeah. So that's interesting, isn't it? Yeah. Yeah, it's not perfect. I don't know why it's not perfect. It was doing the exact same thing in the previous bit of code that I used, that I tried. It was occasionally coming through the 3D node. I don't know why it does that. I couldn't work that one out, actually, so I'm not sure. But anyway. You can see that the terrain color changes over time. That works pretty good. Yeah. Yeah, so I'm going to change the lighting of my terrain. That's going to look a lot nicer, a lot brighter when it flashes. Yeah, it'll look a lot better if I do that. Maybe I'll change the skylight. Yeah, the sky as well as the point light as well, working together. Yeah, so anyway, hope you like that. Cheers.